Hi everyone, let's take a look at the following integration. What is the difference between the first case and the second case? Let's start with case number one. On the left here, there's the integration of x squared with respect to x. What this means is you want to find the antiderivative of x squared. Now, integration or antiderivative is very different from finding the derivative. It is not exactly the opposite, and here's the reason why. When you think about the antiderivative of x squared with respect to x, what you have to do is add the exponent by 1. So 2 plus 1 is going to give you 3. Divide by the new exponent, which is going to be 3. Now, the reason why this is not the only answer is because, again, when you find the derivative of a function, there's one answer. When you find the antiderivative, there are infinite many answers, which means if you add a constant c, and c could be any constant, any root numbers. So for example, c could be 5, it could be -2. There are infinite cases where if you find the derivative, it will give you the question back. So you can double check quickly, and I'm going to use a different color for you. So if I double check, what that means is I'm starting with y equal to x to the power 3 divided by 3 plus c. If I find the derivative dy by dx, this equals to, again, if you apply the power rule, x cubed becomes 3x squared. Don't forget about the 3. When you differentiate a constant, that's going to be 0. And now dy by dx equals to x squared. And if you look at this, comparing to the question, as expected, it is the same. Let's keep going. In the second case, this is not the same as the antiderivative of x squared with respect to x. This really means find the area under the curve, and the curve that we're looking at is y equal to x squared. And you're looking for the area specifically between 0 and 2. So the fastest way to understand this is to sketch the graph. So again, step 1, draw a diagram. If you think about this, and again, I'll set a scale within reason just to illustrate what we're doing here. If you think about y equal to x squared, something you've done back in grade 10 academic math, the graph looks, roughly speaking, something like that. That's y equal to x squared. Now again, this means find the area underneath this graph from 0 all the way to 2. So you want to find this area. That's what the second case is asking. So again, find the area of the curve y equal to x squared between 0 and 2. Now, how do we do this? Again, similar to the first case, first, find the antiderivative. So I'm going to copy the whole question again for you. So this equals to x to the power 3 divided by 3. Again, the difference is you don't add a constant here. Instead, you're going to evaluate this from 0 to 2. You're going to plug in 2, so 2 cubed divided by 3, minus, then you plug in 0, 0 to the power 3 divided by 3. Now, leave your final answer in exact form. So this is going to be 8 divided by 3 units squared. So that is the area underneath the curve y equal to x squared from 0 to 2. Now, to summarize this, again, what is the difference here? In the first case, when you take the integration of x squared with respect to x, this is also known as an indefinite integral. And in the second case, when you're finding the area, these are called definite integrals. If you like more of these videos with respect to integration, please comment below and type in more, M-O-R-E. And once I receive student voice, enough feedback, I will be happy to make more videos on the topic integration. I hope this makes sense.